Hi class, today we are going to take a look at combinations of functions, which is section 1.7. For many of you, this should be a review. You should have seen this before. It may not have been recently, but you should have seen it before, probably in Prop Stat. So we're going to take a look at the arithmetic combinations of functions. Basically, just like two real numbers can be combined using the four basic operations, functions can also be combined using those same operations of addition, subtraction, multiplication, and division to create a new function. A combined function like this is called an arithmetic combination of functions. And if we take a look at a function, there's always going to be some domain restrictions, or we should always be able to identify a domain. And the domain of an arithmetic combination of a function f and g must consist of the real numbers that are common in the domains of f and g. So you need to take into consideration the domain of f as well as g, and then look at the combined domain restrictions. So in the quotient f of x over g of x, there is going to be further restrictions other than just g of x equals 0. So we're going to take a look at some more domain restrictions and talk about domains as we get further into examples. If we take a look at the four basic operations, the sum may be written, well, for all of your operations, sum, difference, product, and quotient may be written like so, where you have f plus g of x, or you may see it written as f of x plus g of x. Same goes for f of x minus g of x, f of x times g of x, and then also the quotient, which we just saw, f of x divided by g of x. So there's just other ways that it can be written. So now let's take an actual example. If we have the function f and we have the function g, and I'm asking you to add the two functions, you are simply taking the function f, which is x squared plus 2x, and adding the function g, which is 2x plus 1. Addition is really easy. Just combine your like terms. We're going to combine our 2x and 2x to give us a 4x in the center there. So we have x squared plus 4x plus 1. Always think about if there are domain restrictions, and in this polynomial there will not be any restrictions, so your domain would just be all real numbers. Be extremely careful though when you get down to this subtraction. Just remember that you have to go in the order that the problem presents. So f minus g means that f should come first. Also, maybe I would suggest putting in some parentheses so you don't make any silly mistakes. You're taking the f function and subtracting the g function. Don't forget to distribute that negative sign. So when we combine our like terms, we're going to be left with x squared. 2x minus 2x are going to cancel, and then we have a minus 1. Again, no domain restrictions there, so our domain would be all real numbers. When you get to multiplication, just remember with multiplication, especially in a problem like this where you have f and g are both binomials, 2x, you are going to have to use the FOIL process. So when we FOIL this all out, we're going to end up with, I'm going to kind of skip a step here, I'm going to end up with 2x to the third plus 5x squared plus 2x. So this is after I FOIL and combine like terms. Again, it's a polynomial. We have no domain restrictions, so our domain would be all real numbers. And then lastly, f of x divided by g of x. Whenever you have division, you should always have domain restrictions. So if we have f is going to be x squared plus 2x divided by g, which is 2x plus 1, you're always going to at least have the restriction that your denominator cannot equal 0. So, oops, I didn't mean for that to be get rid of that. I don't need an equal sign. I wanted to put a comma there, sorry. So we need to say that our domain is going to be all real numbers, given that x cannot equal negative 1/2, because negative 1/2 would make that denominator equal 0. Moving on. We're going to skip the classwork for now. We'll do that tomorrow in class, so don't worry about that. All right. Next section of your notes, composition of functions. This again should be something that you have seen before. Just know that it can be written in two different ways. You can see this kind of fog type of notation, f of g of x, or it may be written like this, where you have f of g of x. For the composition of function f with g, the domain of f of g is the set of all x in the domain of g, such that g of x is in the domain of f. For two functions f and g, to find f of g of x, evaluate f of x by substituting g of x for all x's in f. Now, that sounds very wordy, but once we get to practicing, you will probably remember seeing this before. Oops. Okay, so let's try a couple of problems here. If we have the function f of x, which is 3x plus 4, and g of x, which is 2x squared minus 1, A is asking us to do f of g of x. So we are taking the g function and substituting it into the f function. So I'm writing my f function, but instead of x, I'm substituting in whatever the g function is. At this point, simplify. So I'm going to distribute the 3. So I get 6x squared minus 3. And then add the 4 to the end. Keep going. 6x squared plus 1. I cannot simplify any further, so that would be my final answer. Okay, next I have g of f of x. So this time I'm putting f into g. So in the g function, I have 2 times x squared. Instead of the x, I'm putting in 3x plus 4. Squaring that, and then minus 1. Be extremely careful with order of operations here. You want to do the squaring of that binomial first, then distribute the 2, then subtract 1. So I'm going to be left with 2 times 9x squared plus 24x plus 16, and then minus the 1. Distribute the 2, and then subtract 1. So I'm going to give us our final answer here, 18x squared plus 48x plus 31. And I cannot simplify any further, so that is our final answer. And our last problem here, this time instead of evaluating at x, we are going to evaluate at a value of -2. So we're going to be doing g of f of -2. So that means that we're going to evaluate the innermost function first. Evaluate the function f when x is -2. So I'm going to do 3 times -2 plus 4. So -6 plus 4 is going to give us -2. So I'm now going to, instead of writing f of -2, I'm going to replace that with its value, which is -2. So now I'm doing g of -2. It happened to be the same value, x value here, but it's not always going to happen like that. So the last step would be to take 2 times the -2 squared minus 1 and evaluate that expression. So you're going to end up with 4 times the 2 is 8 minus 1, giving you 7. So in a problem like this where you're evaluating at a specific number, you should end up with a number as a final answer, whereas our previous two we were evaluating at x. So you should be left with an expression. Okay, we will finish the rest of the notes in class tomorrow. Please check my website for the remaining homework problems.